Hi, I'm Ray with Arizonacontrols, and this is our Viper 3D printer. Today I'm going to show you how to adjust the nozzle height to the bed. Fortunately, on a Viper 3D printer, this is very easy to do because the nozzle height is actually adjusted in the firmware by changing a setting on the full graphics smart controller and saving the change to memory. The nozzle height will normally require adjustment if you have disassembled the hot ends or if you increase the resolution of the print in your software. Typically, if you go from fast to medium or high quality, the layer heights will change.
Okay, so here we are in Simplify 3D, and what we're going to take a look at is the difference in layer heights based on the resolution that you choose. So we're going to open this Process 1. It brings us to this screen, and we're going to choose the Layers tab. And as you can see on Fast, the primary layer height is 0.3 millimeters. If we go to Medium Resolution, it drops the layer height to 0.2, and on High, it drops it to 0.1. So anytime you change this resolution, you're going to want to adjust the nozzle, so you need a really easy way to do that.
Let's take a look at how the nozzle adjustment works. In the firmware, there's a value stored on the EEPROM. The value is called the extruder offset. This offset is the distance from the nozzle to the end of the inductive sensor.
Here's a graphic representation of what I was talking about. Here's your extruder nozzle, the heat block, the Z-probe or inductive sensor, and the difference between the distance from the tip of the nozzle to the end of the Z-probe is this offset. And what we're going to do is enter a value, and it's going to make this Z-probe move closer to the bed, which will in turn move the nozzle closer to the bed. Here's how the numbers work. If the extruder offset were set at neutral or 0, the Z-probe height above the bed would be the same as when the machine is homed, which means that the nozzles would be up off of the bed, and that just wouldn't work. So let's say that we were set at negative 0.2, and we went into Simplify 3D and we changed it from fast mode to medium. We know that that layer height change is 0.1, so we would want to change the offset to negative 0.3, and if we went into high resolution, we would change it to negative 0.4. As you can see, this would be virtually impossible to do by hand, which is why we designed the printer the way we did, so that you could do it through the computer and just easily change the numbers on the full graphics smart controller.
Many people use glue sticks, hairspray, and slurries to get their prints to stick to the surface of the bed. In reality, you don't need anything to make your prints stick other than a heated bed and a properly calibrated machine. Specifically, the nozzle height is critical in order to get the quality prints that stick to the build surface. I have created a 1-inch test square to demonstrate the different problems associated with improper nozzle height adjustments. First, let's look at what happens if the nozzle is too far away from the bed. For this print, the heated bed is off. The build surface has blue painter's tape. We are using 1.75 millimeter red PLA filament running at 190 degrees centigrade.
So here we go. And as you can see, the nozzle is too far away from the bed. You can tell because of that snot string that's across the print. You can see where it picks up, and there's gaps in the extrusion. You'll really be able to see it as it starts laying down these layers. Here, see where it's not making it all the way to the edge. Now you might be tempted to think that this is an extrusion multiplier problem, but it's not. You can actually see a gap between each line. This is just a symptom of the nozzle being too far away from the bed.
If you raise the extrusion multiplier in this case, it will make the situation worse, especially when the nozzle is properly adjusted, as you will then be over extruding. Now let's look at what happens if the nozzle is too close to the bed. I'm not changing any of the parameters for the print other than setting the nozzle height adjustment to negative 1.85.
Okay, so here's what it looks like when the nozzle is too close to the bed. Initially it looks like it's doing a really good job, but it's actually pressing down into the plastic. And what this will cause, instead of when it was too far away, we were getting little valleys between the lines. Now we're going to get ribs or ribbing. And if you look at the edges where it's laying down these lines, it's uneven, and we call that puckering. And what it means is that you're going to get a void and an air gap underneath the print, and as it continues you'll kind of see some color differences. With the lighter colors, they're just not touching the bed. The darker colors are adhered to the bed, and I guarantee you this is stuck to the bed very well. You might also think that this is over extruding, but it's not. As you watch this next move, when it starts the second layer, it's going to actually drag through the ribs in the plastic. See it? That's a big problem. So we're way too close to the bed.
Now let's look at what happens when the nozzle is properly adjusted. I'm not changing any of the parameters for the print other than setting the nozzle adjustment to negative 1.55.
Okay, so here we are at the smart controller. We're going to go to Control, Nozzle Height, Adjust Nozzle. We're going to change it from negative 1.85 to negative 1.55. Whenever you do this procedure, make sure that you store it in memory, or it could potentially load the old value and cause you problems down the road. Okay, so here we go. So it's looking pretty good so far. Let's see what happens. I've got a little peel up on that first line. Sometimes that happens. It'll auto-correct itself though. It might leave a small gap on the bottom when it's done. So now we're looking pretty good. Nice flat layers. No gaps in the edges. Nice and straight. No puckering. And of course this is on fast mode. This is the lowest resolution that I have set up in Simplify 3D. I have it set up so that it only prints at 50% speed on the first layer, and then it kicks into high gear after that. So here we go. Looking pretty good. It's always a good idea to use these test squares because they're cheap. It only costs a penny, and it's a quick, easy way to set up your printer before you do a big print. I would have to say that this nozzle height is correct. There's no dragging through the layers. It's nice and smooth. I believe this This should be the final layer. You notice you might think you're seeing a little bit of gapping between those lines, but this is ultra close up, as you'll see when I pick up the test square. I mean, you can see my fingerprints. It's pretty close. So let's peel it up and see what we got here. Pretty good. Take a look at the bottom. There's that gap from that one peel up right at the beginning. See if I can focus this in for you. Yeah, it's pretty nice, pretty flat. It's filled in nicely, and that's pretty good nozzle adjustment.
As you can see, it is very easy to adjust the nozzle height on the Viper 3D printer. If you like this video and want to see more like it, please subscribe below and toss us a like. We always welcome any comments. Please feel free to visit us at www.arizonacontrols.com. Have a great day and thanks for watching.